So today we will tell about the electromagnetic induction and Faraday's laws of electromagnetic induction. So first we will see about that what had Faraday told. He stated that current can also be generated from magnetic field. So he did various experiments. So let's see. So first of all, he took a coil and a bar magnet with north and south poles. So he made the coil fixed and he kept the direction of the magnetic field facing the north towards the coil, and so here we can see that the magnetic field is like this and it is going like this. So an anti-clockwise current will be generated here, an anti-clockwise current. What is anti-clockwise? Anti-clockwise means it will be from east to west. Anti-clockwise means it will be from east to west. So how did he saw that? He used an instrument known as galvanometer for seeing the direction, for analyzing the direction of the current, and he also nextly he reversed the poles. So at that time an clockwise current will be generated, because here this is a south pole and here is a north pole. Then he made both the magnet and the coil fixed. At that time no current will flow, no current flows at that time. Also, when he made the magnet fixed, bar magnet fixed, and he changed the direction of the coil, that means he at first to move towards it and then from it. So then at the same time, then in that case the same phenomenon occurred, current flowed in that coil. So from these experiments Faraday concluded that when there is a relative motion between the magnet and the current carrying conductor or the coil, so at that time current will flow and induced current will be produced, and EMF is also applied, because when there will be when there is no EMF, no current will flow. So where there is a current, there is an EMF. So he named this EMF as induced EMF, and the total phenomena is known as electromagnetic induction. So this phenomenon is called as the electromagnetic induction. This is called electromagnetic induction. Okay, so this is the thing. And now we will discuss about the first law of Faraday. So what is the first law? So in the first law he stated that when there is an induced EMF will be produced when there is a change in the magnetic flux associated with the coil, both associated with the coil. So what is we have told about the what is induced EMF, and now we will tell about the what is magnetic flux. So if there is a coil, suppose this is a coil, or so this is an area, surface area. So these are the magnetic field lines. So magnetic flux is nothing but the total number of magnetic field lines passing through a coil or passing through a surface area perpendicularly. Okay. Not always perpendicular, but we can say that this is perpendicular, this is perpendicular, this is perpendicular. So we can say that what is magnetic flux? Magnetic flux is basically the total number of magnetic field lines passing through a coil. So we can denote the magnetic flux as like this mathematically. That is phi b equal to p into dA. Okay, this is B and this is dA. This is A. So this is the magnetic flux. This is the magnetic field intensity. This B is the magnetic field intensity, and this A is the area, surface area, the area, we can say this is area. This is the first law. So we can, from the first law we can retain, or we can understand the concept of magnetic flux. Okay, from the second law, the second law states, so this is the first law we have told, and second is the second law. What is the second law? The second law is basically tells about the magnitude of the EMF. So the magnitude means, it states that the magnitude of the induced EMF produced in a coil associated with the coil is directly proportional to the rate of change of magnetic flux associated with the coil, and it lasts as long as the magnetic flux lasts in the coil. So I have told a long sentence, so in order to, we can write it mathematically and understand, let's understand what it said. So this is E, that is induced EMF. Okay, this is stated that it is directly proportional to the rate of change of magnetic flux. Magnetic flux, we have written that this is the thing. Some people write this at only phi, but I am writing as phi b, because I have wrote here is B is the magnetic field intensity and I is the area. Sorry, it is a delta phi b, and this is delta t, is the rate of change. So rate of change means there is a time interval. So this is the law, this law states. Okay, so if we remove this proportionality sign, so we have to equal, so we have to give a proportionality constant. So here L is the, we are denoting L as the proportionality constant.